Good morning and welcome to Trig Day 5. And the homework last night looked pretty good, but I decided I would show my answers again if anyone wanted to check. I know a couple people had questions on why their answers were off, so if you were good on the homework, you can kind of skip past these first couple seconds on the video, but if you want to see the work, here's numbers 1 through 3 on last night's homework. And I'm going to go kind of quick, so just pause the video if you need to check something. Here's 4, 5, and 6. 7, 8, 9. Over on the back. There's 10, 11, 12. 13 through 15. And then for the special triangles, if you had 4.5 radical 3 and 4.5, that's obviously fine too. If you're filling in missing angles also. And then for number 18, coterminal, if you look down, coterminal with 120, so here I added 360 twice. Here I subtracted 360 once, both those ended up being 120. Here I subtracted 360, got 120 again, so the only one that's not coterminal, this would be in quadrant 1, is number 3. It would be the reference angle, but just not coterminal. Okay? All right. So why don't you take a second and pause the video and try these. Evaluate exactly. This is just what we did yesterday. These ones we didn't actually do yesterday. It is on the homework tonight, so make sure you know how to do this, so don't flip past this. Evaluate to the nearest tenth. So these aren't nice triangles, so you won't be able to necessarily draw these out and figure them out without a calculator. But you should know now from all that we checked yesterday. Think about what mode you'd have to be in for these, and then type them in your calculator and get your answer to a nearest tenth. Okay, so press pause and try that, and then when you're ready to see it again, you can press play. Pause. That's what you should be checking right now. And here's the answers. Okay, so just to remind everyone where you were at yesterday, I want to do tangent of 7 pi over 4. You have to draw it out. We're in radians, so we're going to have 0, pi over 2, pi, 3 pi over 2, and 2 pi. We're at 7 pi over 4b. Well, there's 4 pizza slices on top. I'm over 4. Another 4 on the bottom. I only need 7. So 1, 2, 3, 4, 5, 6, 7 would be all the way over here. Or the way I prefer to do it, this is 4 pi over 4. This is 8 pi over 4. Since 7 is 1 less than 8, you'd be in quadrant 4. Draw your triangle. What's your reference angle? 45, because you're over 4. So this is 1, 1, radical 2. We're going down over here, so this would be a negative 1. And tangent, using SOHCAHTOA, is opposite over adjacent. Opposite is negative 1, because that's across from 45. Adjacent is 1, and negative 1 divided by 1 is negative 1. Alright, so it didn't say, but if you wanted to check that on your calculator, you could pretty easily. You need to be in what mode? Radian. So mode, I'm in degree right now, so I'm going to switch over to radian. And then if I just type tangent of 7 pi over 4, I end up with negative 1. Check. Okay, so that brings me to these ones too. If I want to evaluate to the nearest tenth, sine of 43, again, 43 isn't a special triangle, so there's no way to draw it out like this. I'm in the first quadrant, but I wouldn't know the sides. I can change to degree mode, because this is 43 degrees, and I would just type sine of 43. It's as easy as that. 0.681, so nearest tenth, 0.7. And for the second one, cosine of pi over 4, My mode is radians. To change the mode, because pi over 4 is radian. And I type in cosine of pi over 5.809, nearest tenth, 0.8. Okay, so there are a couple questions like that on your homework tonight, and really no work to show other than your answer. More than 18% of animal owners share their beds with their pets. Blech. Okay, today's stuff. Let me get to that. Give me 1 second here, sorry. Here are today's notes, and there is a note sheet for today. If you can print that out, it's probably the best option, but if you'd rather write it on a separate sheet of paper, if you don't have a printer, that's fine too. So we're going to talk more about evaluating today, but now we're going to talk about how to evaluate those quadrantals, because we've drawn quadrantal angles before. Remember, ones that land on the lines. We haven't done any evaluations with them. There's been none of them in the last couple days. So in order to do that, we have to talk about something called the unit circle. So the unit circle is a circle who's centered at the origin, like this one in the picture, with a radius equal to 1. That's kind of the key. Unit means 1. So if the radius equals 1, remember the radius is from the center out, then you should be able to tell me what all of these points are. If this is a radius of 1, then I'm going out 1, up 0. So this point over here is 1, 0. What would this point up here be? Same idea. I'm going over 0 but up 1. So this point would be 0, 1. Over this way, would be negative 1, 0. And then going down would be 0, negative 1. Okay, so this picture, I drew it the best I could. I mean for this triangle to be hitting the circle right there. So just put a big dot so that it looks like it's hitting. But if this is a triangle on the unit circle, what's the hypotenuse length going to be? Well, if this is really going from the center to the edge like I want it to be, and it's a unit circle, this should be 1. Okay, now this is some random point on the circle. I'm going to call it xy. So for the other sides of the triangle, we can say if this is the point xy, well then I'm going over x, so this is x down here, and I'm going up y, so this is y over here. And this is just some random angle theta. I drew it in the first quadrant, but it could be drawn anywhere. Okay, so let's use this triangle. On the unit circle, sine of theta, what's sine always equal to in a triangle? Opposite over hypotenuse. So here, the opposite is y. The hypotenuse is 1. And what's y divided by 1? Just y. What is cosine of theta? Cosine of theta is adjacent over hypotenuse. Adjacent is x. Hypotenuse is 1. X over 1 is just x. So, on the unit circle, sine of theta is equal to y, and cosine of theta is equal to x. And that's true of any point on the unit circle. So with a picture like I just drew, I'm probably not going to use a unit circle to evaluate an angle like this. Like if this was 30 degrees, I don't want that hypotenuse to be 1. I'm going to use the special triangle that I know. But, excuse me, if I land on one of these quadrantals, I can still use this idea. What about tangent of theta? Well, using that same picture, tangent of theta is opposite over adjacent. So on my triangle up here, what's tangent? Y over x. But what did I just say y was? Y is sine of theta. And what's x? Cosine of theta. So that kind of gives us a new way to find tangent if we wanted to. So tangent of theta on the unit circle is always equal to y over x. And we also see that tangent of theta is always equal to whatever the sine of theta is divided by the cosine of theta. And this is your first, it's called a trig identity. And a trig identity is true for all angles theta. Okay. So how do I remember this? Well, my key for remembering sine of theta and cosine of theta is alphabetical order. If you were to write sine and cosine in alphabetical order, cosine would come first, sine would come second. Similarly, if you write x and y in alphabetical order, x comes before y. So cosine, the first one in alphabetical order, goes with the first letter in alphabetical order, x, and then sine goes with y. I want to explain this tangent thing a little bit more. So it says down here, find tangent of 120 degrees in two ways. If I asked you to find tangent 120 yesterday, what would you have done? You would have drawn this out. So 0, 90, 180, 270, 360. You'd be in which quadrant? Over in quadrant 1. You draw your triangle down. And 120 means that this reference angle is what? It's attached to 180, so you got to subtract them. So this is going to be 60. So next to 60 is always the 1. The hypotenuse would be 2. Radical 3 is over here. And the 1 would be negative because I'm going to the left. So the way I would normally tell you to do tangent of 120, and I would still tell you to do it this way, is to draw the picture, do opposite over adjacent. Opposite is radical 3. Adjacent is negative 1. And I get negative radical 3. That's one way to find tangent of 120. The other way, which in this case isn't going to be any easier, is to say that tangent of 120 degrees, so I'm using this formula right here, theta is 120, equals sine of 120 over cosine of 120. Now I'd still have to draw the picture. Sine is opposite over hypotenuse, so the opposite is radical 3. The hypotenuse is 2. Over cosine of 120. Cosine's adjacent over hypotenuse, so adjacent's negative 1. Hypotenuse is 2. And you have a complex fraction. How do you deal with complex fractions? Multiply by the LCD, which would be 2. So I multiply this whole top by 2, this whole bottom by 2. Cancel, cancel. I have radical 3 over negative 1. And you can see I get the same thing, negative radical 3. So there's two ways to find tangent of 120, just using opposite over adjacent or using that formula. Now, obviously, using the formula is way trickier with a situation like this, so I would never do the second way if I had an option. But sometimes with the information you're given, the second way might be the only way to do it. So just know that both of them are valid ways to do it and that you could do it that way. Okay, over on the back of the note sheet, the other thing I wanted to talk about today is using the unit circle to evaluate trig functions of quadrantal angles. Okay, so first I want you to remember the quadrantals. They're those ones that you always label. 0, 90, 180, 270, 360. If I kept going, 450 would be the next one, etc. What are they in radians? I think you know these. These are 0, pi over 2, pi, 3 pi over 2, 2 pi. You know what 450 would be? What's the pattern here? 0, 1 pi over 2. This is really 2 pi over 2, 3 pi over 2. This is 4 pi over 2. This would be 5 pi over 2, etc. So what you want to remember is if you have any number pi's over 2, that's a quadrantal. So now you know pi over 4 is always a 45, pi over 6 is always a 30 degrees, pi over 3 is always a 60 degrees, any over 2 is some quadrantal. And be aware that if this is an even number for n, you're not going to have a fraction at all. If it's not a fraction at all, it's just a reduced quadrantal. Okay, so evaluate exactly without a graphing calculator. We're going to check on the calculator still, and then provide a sketch. So I am expecting to see a sketch for any quadrantal still. So sine of 0 degrees. So I'm going to still label just like always, 0, 90, 180, 270, 360. The only difference is 0 lands on the quadrantal. That's where I am. So I know it's a quadrantal, so you got to be thinking unit circle. And I want this point. And it all goes back to the idea that a unit circle has a radius of 1. So this point right here is the point 1, 0. Is sine the x or the y? Remember alphabetical order. Cosine comes before sine in alphabetical order. So cosine is x, sine is y, because x and y come before each other in alphabetical order too. So I want the y value here. The y value is 0. So it's a little bit easier. I'm in degree mode. This will obviously give me that. If I type in sine of 0, it tells me 0. Okay, cosine of 180. Keep labeling 0, 90, 180, 270, 360. We know 180 is over here. If you're on a quadrantal, think unit circle. What point would be over there? It's going left, so just think of a regular grid. I'm going -1 up 0, -1, 0. Cosine is x or y? X. So I want the x coordinate, and my answer is -1. The cosine of 180 is -1. Cosine 180, -1. Really easy to check. All right, tangent of 270. 0, 90, 180, 270, 360. We know 270 is down here. That point is what? 0, -1. Tangent's tricky. Remember, tangent's sine over cosine. So it's y over x. So what's the y coordinate here? -1. Over what's the x coordinate? 0. And what's -1 divided by 0? You can't divide by 0. This is undefined. So the answer is not 0. It's undefined. And the calculator can even show you that. If I type in tangent of 270, it tells me error domain. The domain error is you have a 0 in the denominator. It's undefined. Okay. to the next row. Cosine of pi over 2. It's the same idea, but now I'm in radians. 0, pi over 2, pi, 3 pi over 2, and 2 pi. I'm over 2, so I'm definitely a quadrantal. So that's going to be right here. Draw your unit circle. What point would be up here? It's 0, 1. Cosine is x or y? It's x. So the x coordinate is 0, and my answer is 0. What do I have to do first in my calculator if I want to check this? I have to switch my mode, because now I'm in radians. So mode radian, and then I can do cosine of pi over 2. 0. Tangent of 360. Also a quadrantal. It's the same as 0. So it's still on the unit circle. What point is over here? 1, 0. Tangent's the trickier one. You got to think sine over cosine. Sine is y over x is cosine. So the y coordinate here is 0. The x coordinate is 1. 0 divided by 1 is 0. So tangent of 360 does exist, and it's 0. I'd have to go back to degree mode one more time and say tangent of 360 is 0. All right, cosine of 0. I might not even need a drawing because we just did it on the last one, but just for now, do a drawing for all of these every time. Here's 0, 90, 180, 270, 360. 0 is right here. Same drawing as the last one, but if it's the cosine, what value am I looking for? The x coordinate, so we get 1. Any questions? Hopefully you're getting the idea. Okay, for these last 2 rows, why don't you pause the video, try it on your own, see if you can get these. I threw some negative angles in here and also some that are bigger than one time around. So pause this, try these 6, and then when you're ready, hit play, and I'll go through the answers for you. Are you ready? Here we go. Sine of 3 pi over 2. Label your sides. We're over 2, so we know it's going to be a quadrantal, and it lands right here. So there's your unit circle. The point down here should have been 0, negative 1. Sine is the y coordinate, so you should end up with negative 1. Tangent of 90, obviously quadrantal. You're landing right here. The point up here is 0, 1. Tangent sine, which is y, over cosine, which is x. So the y coordinate is 1, the x coordinate is 0, and what happens when you have 1 over 0? You get undefined. Sine of pi. If it's not a fraction as a radian, it's also going to be a quadrantal, and it's obviously over here. This is the point negative 1, 0. Sine is the y coordinate, and the y coordinate of that point is 0, so your answer is 0. Okay, so remember negative angles work the same way, except we go clockwise. So this is 0, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So negative pi over 2, it's over 2, so it's obviously a quadrantal. Unit circle. This point should have been 0, negative 1. It's like where 3 pi over 2 normally is. Cosine's the x-coordinate, so your answer is 0. Okay, sine of 135, I'm back to degrees. Where's 135? It's not a quadrantal. I tried to trick you. It's in the second quadrant. So this is one like yesterday. And on tonight's homework, there will be some like yesterday mixed in. They're not always going to all be quadrantals. So that's 135. Draw your triangle down. I'm attached to 180, so 180 minus 135 is 45. That's the 1, 1, radical 2 triangle. This will be negative 1 because I'm going to the left. Use SOHCAHTOA, so I'm just doing opposite over hypotenuse. Opposite is 1, hypotenuse is radical 2. And if you multiply top and bottom by radical 2, what do you get? Radical 2 over 2. And remember, you can still check those like we did yesterday. So if I'm in the right mode, which I am, and type sine of 135, I get big long decimal. If I type radical 2 divided by 2, I get same big long decimal. So I know I'm right. All right, and the last one. Back to radians. 0, pi over 2, pi, 3 pi over 2, 2 pi. Now, I'm over 2, that tells me for sure it's a quadrantal. And sometimes it helps just to count it out. This is 0, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. If I keep going, 5 pi over 2, 6 pi over 2, 7 pi over 2. I'm down here. So over 2, just recognize that it's a quadrantal. So the point would be 0, negative 1. Sine is the y-coordinate, so my answer is negative 1. Okay, so that was a lot of examples, and I hope that you understood that. If you have questions or problems, please ask me, but you should have tonight's homework, Unit 13, Day 5. Good luck.